Hi everyone, I'm Dr. Suresh Anand. The course title is Essentials of Object Oriented Design and Programming. So, in this course, we are having five modules. In this module one, we'll be discussing about the introduction to OOPS. So, these are all the topics to be covered, like object oriented programming basics, introduction, features of C++, IO operation, data types, variables, static variables, constants, etc. So, let us start with the introduction to OOP. So the object-oriented programming is a methodology, or we can call it as a programming paradigm, where we can design a program by using classes and objects. So it is a programming methodology, so based on object instead of just having functions and data in a program. It also refers that languages that use objects in the programming. So the other way, OOP aims to implement the real world entities using inheritance, polymorphism, encapsulation in programming point of view. And coming to why we need object oriented programming. So the prior one is POP, which is a procedural oriented programming, which is a top down design where we are taking a problem and dividing into sub problems. So like a pyramid. So starting from the huge problem, which is going to be divided into small problems. So that is what called the sub procedures. A big problem can be divided into small one. That is what actually POP. So the problem in the POP is if you do any change in the program, it is affecting the entire program. So you have to think about the entire program. So this problem can be addressed by the OOP because object oriented is supports the modularity. So where if you change a code a snippet, which won't affect the other part of the module. So that is what the advantage of the OOP. And the aim of OOP is try to increase the flexibility and maintainability of the programs because of programs created by using object-oriented language. So these are all modular. Modular means the a program is divided into small modules. Each module is independent. If you do any change in one module, which will not affect the other module. So it is easier to develop and simpler to understand after development. So this is why we are going for the object-oriented programming than the POP. And let us see some object-oriented programming concepts. So there are some seven primary concepts, like starting from object, classes, abstraction, encapsulation, inheritance, and polymorphism. So these are all the primary components of the object-oriented programming. So let us see one by one what is what. So let us see what is object. So object is the representation of the real world entity. So if you take any real world entity like a chair, table, uh, as a fan, pen, etc. So anything you can take. So you can represent the real world entity in a programming scenario. So that is what object. So any entity that has a state and behavior is known as object. An object can be defined by the instance of the class. Object can be defined as an instance of the class, which means from the class you can instantiate or create an object. That is what the meaning of this statement. And coming to second one, class. So class is nothing but a collection of objects or group of objects. So these objects are having common properties. So the members of the classes can be accessed by the object. So the class can also defined as a blueprint, which is containing a variables and methods. So inside a class, so you can see you can have variables and method. So these variables and methods are accessed by the objects of the class. So let us move on to the next component, which is encapsulation. Encapsulation means wrapping or binding the data and function together, which is called as encapsulation. So because using this encapsulation, you can secure the data from the other methods. Because by wrapping a data and function in a one single unit, the non-member entity of the class cannot access the encapsulated or secured data and methods. So next concept is abstraction. So abstraction is hiding the implementation and displaying only essential details to the user, which means uh, if you're having a data and function together wrapped by encapsulated, and hence it is also providing the abstraction. So because it is hidden to the non-member of the class, right? So in OOP, abstraction is implemented automatically while writing the code in a class and object, which is again encapsulation. Okay, so next concept is inheritance. So literal meaning is acquiring the properties. That is what inheritance, or acquiring the entity. So here, inheritance can be said as, so acquiring the properties and behavior of one class to other class. For example, from a parent is offering something to the children. So the parent class is called as base class. The class which is getting the property is called as child class or derived class. Okay, so acquiring properties and behavior is a child class. So offering class is parent class. That is what inheritance. So we are applying the real world example, real world scenario in the programming. That is what object oriented programming. So next concept is polymorphism. So it is two word combination, poly and morph. Poly means many, morph means form. So taking many form. So one entity can act differently, or one entity can be implemented differently, or one task can be performed different ways, is known as polymorphism. And so we can see this example, abstraction means hiding the implementation and displaying only essential details to the user. So to drive a car, I need not know how the engine is actually functioning. So the basic functionality is steering wheel, brake, clutch, accelerator is sufficient to drive a car. So no need to know how the car engine is working. So that's what called as abstraction. And coming to encapsulation, I told you already. So binding of data and function together, variables and methods together. So take this capsule example. So inside the capsule, we are having the many medicines. So we can have, these are all datas and the methods or functions. So together it is bundled in one capsule, which is called as a class. Encapsulated entities, encapsulating variables and methods, we can call that as a class. So take out this example, inheritance, acquiring the properties from parent to child. So here in biologically, the child is acquiring the dad's skin complexion, height, eyebrows, hair, everything, right? So in same way in programming also, the child class is acquiring the properties, variables, methods from the parent class. That is what called as inheritance. So here the class which is offering is called as super class or base class or parent class, and the class which is receiving is called as subclass, derived class or child class. Okay, and take out this example, polymorphism. One person taking many forms depending upon the scenario. So first one is family head, next one is a traveler, or here in executive in an office, and manager in an office, and a customer in a grocery shop or supermarket. So so one person takes act differently depending upon the scenarios and the environment. So that is what called as polymorphism, taking many form. So these are all the OOPS concepts and examples. So that is what this chapter. Thank you all. Hello everyone, welcome back to the course Essentials of Object-Oriented Programming and Design. So in this module 1, we will be discussing about Introduction to OOPS. In the previous session, we discussed about the basics of object-oriented programming. In this session, we will be discussing about the features of C++. Actually, the object-oriented programming is implemented in by using C++ programming language. So we'll be discussing what are there in the C++. So let us start. So C++ was actually designed by Vijarny Stostop in late 1980s in AT&T Bell Laboratory. Actually, it is an ancestor of C++ is actually C. We can call C++ as a C with the classes. Also developed by Stostop in 1980s. C with the classes is actually heavily influenced by these languages called C and similar. So C++ is simply a better C, providing the type checking, overloaded function, and many other improvements which is not in C. It is largely superset of C. So C++ adds object-oriented programming scenario to the language C. So simply C++ can be called C with the classes. Okay, and C++ covers the what all the problems or drawbacks in C, so that are all addressed or improved in C++, like memory management. OOP support is not in C language, and libraries are not broad, or it is limited in C language, and there is no built-in exception handling. So these are all some drawbacks in C, which are all addressed and improved and added to the C++. The support of classes, type checking, function overloading, operator overloading, storage management, constant types, pointers, references, special functions like inline function, friend function, and virtual function. So these are all new add-on to the language C, which is called C++. And you can check out some of the important features of C++. So as I already told you, it is object oriented, mission independent, simple, high level language. Of course, C is high level language, C++ is also high level language, compiler based. It supports dynamic memory allocation, case sensitive, like a C++ also case sensitive. It is very popular as C, and existence of libraries. Already some libraries are available in C, so that can be retained in C++ too. A speed. So these are all these some important features of C++. Let us see one by one. Object oriented. So C++ supports object oriented, as we discussed in the previous session. Machine dependent. So the executable is not platform dependent, so it can run on any compiler, any C++ compiler, irrespective of the platform. It is simple. So the programs are can be broken into logical units and parts. It supports modularity, and it is a high level language. So C is a mid level language, and C++ is a high level language. So it is very popular because of it is base for many programming languages. Already told you it is a compiler based, so executable file used to run on the machine. So compiled and then executable, and memory management. So it allocates a memory of a variable or any array and run on time. So dynamic memory allocation supported, and libraries. So coming to libraries, so C++ having lot of built-in functions and libraries. So these are all the features of C++. And moving on to the next sessions and all, we will be discussing how to write the classes in C++, how we can utilize the libraries and functions C++. In coming sessions, we will be exploring. So that's all. End of this chapter.
Hi everyone, I'm Dr. Suresh Anand. I am a professor at SRM University, India. So I'm having nearly 20 years of experience in teaching in computer science and engineering. I have published several textbooks, research papers in reputed journals. My research and innovation results in multiple or many Indian design patents. My research interest area includes image classification, image processing, computer vision, machine learning, deep learning, and human-computer interaction. I'm an active member of IST, ACM, IEEE, and CSI. So that's about me. So the course title is Essentials of Object-Oriented Programming and Design. So I'm delighted to welcome you to this course. Whether you are new to programming or already having some basics, this course will help you to build a strong foundation in object-oriented programming and design principles. Today, the software systems are becoming increasingly complex. From mobile applications, websites, to enterprise software and embedded system, the developers need an efficient way to design, develop, and maintain a software. So this is where the object-oriented programming, commonly known as OOP, plays a main role. In this course, we will learn to think how the software in terms of objects, classes, and their interaction. So we are having five modules in this. Module one is the basics of OOPs or introduction to OOPs. Module two, methods and classes and polymorphism. And the third module is inheritance. And fourth one is generic programming. And the last one is STL, standard template library. So in this course, we'll use C++ as our programming language and gradually explore the powerful features of C++. So we'll begin with the basics of OOPs, understanding concepts such as classes, objects, abstraction, encapsulation in the module 1. And also we are covering data types, variables, IO operations, type conversions, control structures, and arrays in the module 1. So as we progress, we will study constructor, destructors, polymorphism in the module 2, which help us to create flexible and reusable software components. And third module, we'll explore the inheritance, one of the most important concepts in OOP, and learn how the software components can be extended and reused efficiently. So the course also introduces the advanced topics such as templates, exception handling, virtual functions, abstracted classes, and generic programming techniques. So these concepts will help you to write a robust and professional quality software. In addition to programming concept, this course emphasizes the software design using UML. UML is a unified modeling language, which is a visual language to represent the software as a document or a diagram before its implementation. So using this UML diagrams, like use case diagram, class diagram, sequence diagram. So these are all the several UML diagrams will help you to understand how the software systems are designed and communicated in professional software development environments. Finally, we will explore in the fifth module, we'll explore STL, which provides a powerful ready-made data structures and algorithms such as vectors, list, map, stack, etc. By the end of this course, you will be understand and apply the object-oriented programming concepts. You may develop the programs in C++ and design a software system using UML diagrams and apply inheritance, polymorphism, abstraction effectively, and handle the exceptions and create a generic programs using templates. Also use STL containers and algorithms to build efficient applications. I encourage you to actually participate in this course, practice the programming examples, and complete the exercises exercises provided at the each module. Learning the programming is not just about understanding the concept; it is also about applying through the regular practice. Thank you for joining this course. I look forward learning with you throughout the exciting journey into the object-oriented programming design. Come on, let's start.
Hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. In this module 1, we'll be discussing Introduction to OOPs. In the previous session, we discussed the features of C++. In this session, we'll be seeing about IO operations in C++. Since the OOP concept is going to be implemented in C++, we'll be exploring the features of C++ and the IO operations in the C++ now in this session. So let us start with the IO operations. See in C++, IO operations happens as a streams. So we're sending the data, receiving the data from input stream to the output stream. So the data is going to be traveled as a stream of bytes or sequence of bytes. So it is the source as well as the destination for the data, right? So in C++, programs read the data and send the data to by using the streams. So input by the stream to the output also via the stream. The streams are related with the physical device such as a monitor or with a file stored in a secondary memory. Okay, and for example, in C++ and C both are streams only. So here we are having two types of stream: text stream and the binary stream. So text stream is nothing but a sequence of characters divided into lines, which each line being terminated by the /n. So sequence of characters can be sent as a line of characters. That is what the text stream. Binary stream. So here the data values ones and zeros are sent as streams using their memory representation. So text stream as a characters, binary stream as a ones and zeros. And coming to the IO stream in C++, the header file IO stream, angular bracket IO stream, it defines the input output operation by using the streams called cin, cout, and the cerr object. So these are all the objects from the IO stream class. So cin object, which is used to read the input from the input stream. So standard input stream to read the input stream, it is the instance of the iStream class or input stream class. Similarly, the cout is a output stream. So it's an object used to send the output to the output stream, maybe the display or maybe the print. So the cout is a instance of the OStream class. So iStream, OStream. So together we'll be having IOStream. And cerr is a standard errors streams notifying the errors in the input and the output stream. That is in the IO stream. Okay, so by using cin, we can read the value from the input stream. So we'll be using the overloaded operator. This two greater than symbol, which is called as overload operator. Similarly, cout is the object which is used to read the uh, values from the output or send the values to the output. So by using the overloaded operator, left shift operator, this is the right shift. So two less than symbol are two overloaded left shift operator used to read the send the value to the output stream. Overloaded input operator, I mean, right shift operator used to read the input from the input stream. So the object is cin and cout. So these are all the operator to read and write the values, or to read or send the values to the output stream. Let us see the example, understand easily. So check out this cout. Cout is the object overloaded left shift operator. So this followed by string of characters with the ended with semicolon. Send these string of characters will be sent to the output stream or to the display. Coming to this one, scene is the object overloaded right shift operator. So used to read the value through this variable name. So name is actually a variable. So you have to declare as a string of characters or a character or string. And cout is the object and output stream overloaded operator, and the string enclosed with the double quotes will be displayed in the output screen, and user is entering this value, enter the value right with the name that will be displayed by the cout. Okay, that is what the scene and cout objects of the IO stream or iStream or O stream respectively used to read the value and send the value to the output stream. So here, yeah, the operator is the overloaded left shift operator. We can cascade the operator. Say for example, check out this example. I'm entering two values at the time, so you can cascade the two inputs by cascading the input stream operator. So cin input operator M1, again cascaded input operator and the M2. So you can cascade. So like this cout also can be used together. Cout cout cascaded output stream, M1 cascaded output stream, and M2. So together two values can be sent to the output stream. So both cin and cout can be cascaded with the respective input stream and output stream operator. Okay. So next is let us see reading and writing by a single character. So let us assume this code IO stream is the hash include IO stream is the header file for C++ input output stream, right? So variable declaration, and I'm asking the user to enter a choice. User is entering one single character. So there is a function called get, which is in the input stream. So object dot function. So that is the way to call the method in the iStream. So the scene is the object of the iStream. Okay, so cin object dot the method, and inside that method I'm passing this parameter c or character c variable c. So which means by using the function I'm reading a single character, that's it. So the whatever the character I read by using the function, I'm sending to the output stream. Cout c means it's going to be displayed. So the same way in check out this code, object dot get, no parameter inside the get function. So in that scenario it is returning a character that will be stored in this. Okay, so user is entering the value by using the input operator input object cin I'm calling get function. This function is going to be reading the value from the terminal, and that value will be sent to the character C. So both the statements are same. So here inside the function I'm passing the variable name. So here inside the function nothing. So the function is returning the single character from the input stream, and that will be sent to the character C. So both are same only. Okay, so reading a single character by using the get function, by using the cin operator. Cin is the HTML operator. Check out the next example. So I'm going to read a string of characters or line of characters, a string. So for that I'm declaring the variable as a string. So in the previous example I declared the variable as a single character. So I'm going to read the single character by using get function. So here the same program, I'm going to read a line of characters. So for this I have to write like this. So get line is the function. Inside the function I'm passing two parameters. First one is the object, second one is the variable name. So whatever the variable is going to, whatever the string of characters read by the getLine function will be stored in the emp name by using the cin operator. The same function can be written like this also. Object dot getLine function. So I'm going to read the line of characters, so it will be stored in emp name string, and here I'm limiting 20. So here I have to specify the function. In this way, if you call a function, I have to specify the how many characters we are going to read in a line. So you have to specify how many characters in a line. So that will be 20 here. So 20 characters I'm going to read. Maximum 20 can be read by using the getLine function, and that will be stored in emp name. So both the statements are same. So here there is no limit for the characters. So here I'm limiting the characters. After that, I'm just displaying the what is there inside the emp name. So in these two programs, we explored reading a single character and reading the line of character, which is a get line. Okay. So moving on to the next topic, which is a formatted input output operation. While sending the output stream output to the output stream, so we can define the how it would be in the output. That is what the formatted IO operation. Check out this function. So by using the function we can format the output. The function name is width, precision and fill. Let us see one by one. So width is the function we can define the column. In a column you can fix the values. So here I'm calling the function, the output stream is cout dot width, and width is my function. Inside the width function I have to specify how many columns you wanted to fix it. So here check out the example. So 6 column I'm fixing and couting 1 2 3 9. So only I'm using 4 positions only. So remaining 2 will be empty. So actually 6 column here actually occupied, I mean created. Out of the 6 column, only 4, 1 2 3 9 is occupied. So remaining 2 will be the prefix to the 1. So here it is actually 2 column will be there. It is not displayed actually. It will be there. And check out the precision. So precision is the function we can specify limit how many numbers after the decimal point. So check out this example. Cout dot precision is the function name 3, which means after dot I'll be limiting with the 3 numbers. So 1.234 only. So how many digits can be displayed after the decimal point? That is what the precision. And the next one is fill. So cout dot fill, whatever the character you wanted to fill it. So check out the output. Cout dot fill, ash is the character I wanted to fill. So this is what I have to define. After that I'm using a cout 1 2 3 9. So total width is 6 actually. So I have to specify how many columns I'm actually allocating. And out of 6 column only 4 is occupied and remaining 2 will be empty. So actually here empty is not displayed in this here example. So here I am specifying what is the fill value. So fill value is ash symbol. So ash symbol is filled in this 2 positions. So because I limited with the 6 column. So out of 6 column only 4 is utilized and 2 will be filled with the ash. So this is a way where you can use the function to format the outputs. Check out the width and you can set a precision for the floating point numbers, and you can fill the unused empty spaces by the specific characters. Let us see the another example, which is by using manipulators. Same IO operation by using manipulators. The manipulators can the same way, but we can use the function called different function called set width, set fill, set precision. Let us see the example. To use you can format by using either this function or by using manipulators. if you're formatting by manipulators, you have to include the io_manip.h in the header file. So this is the built-in file available in C++ in IO stream. If you want to use manipulators, you have to use this io_manip.h header file in the program. So let us see the example. The same functionality only, but here manipulators are used, no functions. So here I just used io_manip.h in the header file. The same example. So cout set w. Set w is the function name, and inside that I will specify how many columns. Six columns. So 1, 2, 3, 4. 1, 2, 3 lines has actually used. The remaining 2 is empty. Next one is set precision of 3. So cout 1, 2, 3, 4, 5, 6, 7. So after the floating, after the decimal point, so how many digits you want it will be using? 1, 2, 3, 4. It's actually, it is rounded off. 1, 2, 3, 4, 5. Set fill is actually filling the set fill this character with this set width. I have to use this set w, set width of 6 and 1, 2, 3, 9. So 1, 2, 3, 9 will be filled, so remaining two places will be filled with the hash character. So very simple. Set w, set precision, set fill are the manipulators, with set precision and fill are the functions. So either you can use manipulators or function. So this is how you can format the output in C++. Yeah, the example by, so first you can check out this example. So to use manipulators, I have to use the io_manip.h, and this precision, width, fill are the functions, normal function, and these three, set w and set fill, are the manipulators. So both will be generating the same output only. So that's it. So IO operations in C++ is over. End of this current chapter.
So welcome back. The course Essentials of Object-Oriented Design and Programming. So we are in the module 1, Introductions to OOPs. In the module 1, we were discussing several topics like say Introduction to OOP, features of C++, and IO operations. In this session, we will be discussing data types in C++, variables in C++, such as static variable, constants and pointers in C++. So coming to data types, we are having three broad category in C++. So basic type, derived one, and the user defined. In the basic, the integer, character, float, double, void are the basic data types in C++. In derived type, we are having pointers, functions, references, and the arrays. So coming to user defined data type, we are having structure, class, union, enumerated, type def are the user defined data types in C++. So moving on to the variables. So variables in C++ are name given to value in a memory location. So that is what called as variable. A variable is identifier or denoted by a variable name. So variable is a sequence of characters or letters or underscore. So that is what variable name. We are having some rules for defining a variable name. Variable name can have already, I said, the one or more letters or digits underscore in between, but the variable name should start with the numbers, letters, underscore, not a number, not a special symbol like punctuations. And the variable name should reserved word should not be, the reserved keywords should not be variable name, and variable name must begin with a letter. So these are some rules for declaring defining the variable name. And check out some valid or invalid here. So the first one is int is a data type, and age is the a valid data type. So the valid variable name. Check out this one. So character name one. So name one is the one is number as n, so it is also valid. But check out this one. So int first place. So in the first place, one is the number. The first letter should be a character or letter or underscore, not a number. So this is invalid. And this one, so double total amount. So in total amount, there is a white space in between these two words. So this is the invalid variable name. If you want to use two words, so you can use underscore in between. Okay, so coming to this one, float net worth. So here also hyphen is not allowed. Punctuations and special symbols are not allowed in between. So this is an invalid. And check out this one. So int char. So char is the data type. It is a reserved keyword. So you should not use this as a variable name. And last one also we are having punctuation in between. So it is an invalid. So these are all some examples of variables in C++, valid and invalid variables in C++. Moving on to the data types in C++, we are having based on the scope, local variable, static variable or class variable, instance variables. Let us see one by one. Local variable declared within the method of a class or within the function of a class. The scope is within the method. Static variable or class variables are variables having only one copy that is shared by all the objects inside the class. That is what static variable or class variable. So, instance variables are variables declared in a class but outside the method. That is what the instance variable, or we can call that as a object variable. Okay. And the constant, coming to constant, so constant is something fixed, so it doesn't change. In C++, constant can be declared by the keyword const. Let us see how to define a constant. So constant value doesn't change, as we know very well. So the constant is actually explicit data value defined by the programmer or developer. And check out, these are all some types of constants in C++: integer, floating point type, character type, and the string type constants. Let us see some example for constants. So before that, we are having some rules for declaring the constant. The first one should be written in capital letters, no blank space in between. If you're using hash define for declaring a constant, there is a space between hash define and the constant name. That is what given over here. So let us see the example. So this is the syntax for declaring the constant. So const data type and the constant name and the value. So example, const keyword, data type is a float, pi is the constant name and whose value is 3.14. So this is the statement which is going to be executed, compiled by the compiler. Then only the pi constant takes the value of 3.14. Whereas check out this one. It is a hash define, it is a preprocessor directive where the constant is given in the only capital, a space between define and the constant name, and the value also given over here. So this preprocessor directive is not needed for compilation. It is excluded for the compilation. So whenever you need a capital PA, which is going to be taking this value, it's another way of representing constant in C++. And moving on to the pointers in C++, pointer is a variable which is used to hold the address of the another variable. That is what actually a pointer. So pointer is a special provision in C or C++ or programming languages used to point some other variables memory location. So whenever you declare a variable, so what happens is some memory is allocated. In that memory is having some address. So if you declare a pointer variable, you can reference or point the pointer variable to that memory address. So that is what actually the two statements. So syntax is data type, asterisk symbol, and the pointer variable. So here integer pointer. So int asterisk p is a pointer variable and sum is a normal integer variable. So how to assign? So assignment is very simple. So pointer variable without asterisk p equal to address of the same type of, because pointer is pointing the similar type of, for example, the integer pointer points only the integer variable. So that is what actual rule. Let us see the example program. You will understand clearly how the pointers is actually working. So check out this code. So hash include iostream. So iostream is the header file for C++, and namespace is going to be this one, and int main, integer pointer, and sum equal to 10, and here the pointer variable assignment is p equal to address of the sum. So here I'm displaying the address of the sum. So the address of the sum variable is 7712, and here I assigned the p to the address of the variable sum. So I'm just displaying the p. So p is the address of sum. So it is 7712, and ampersand p is going to be the address of the pointer. So the pointer variable is having an address, that is the address of the pointer. And then the last one is asterisk p. So value at the address. So value at this location is value at the address of sum is 10. So 10 will be displayed over here. So this is how pointer is assigned, and we can take the variable and we can explore how it is working. Let us see the another example. So check out this example where I'm having array and pointers. So here the array name is ARR, whose size is 5, and these are all the variables values initialized to the array, and integer pointer name is PTR. So assignment of the pointer PTR equal to, generally we used to PTR equal to ampersand of the variable, but here what they given is PTR equal to ARR, which means, so in an array, so the first element can be referred like this. So ARR is nothing but address of the first element. That is what ARR. So here I just explored how the pointer is actually working. Asterisk ARR is nothing but, so ARR is the address of the first element. So value at the first location is 1. Okay, check out the output. And this ARR is going to be address of the first element. So address of the 1 would be some address. 680 is the address. So asterisk PTR is the value at the PTR. Value at the PTR is value at the ARR. Value at the ARR is 1. So asterisk PTR is 1. Check out the output. And PTR is nothing but address of ARR. So this PTR and ARR both are same. So PTR and ARR, so both are 680, 680. That is what this simple, how the pointer is actually working with the arrays. Check out this code snippet where I'm having a for loop iterating 5 times. So visiting every single element and displaying the value. That is what actually task. So here what I assigned is PTR equal to first element address is given to PTR. If I print asterisk PTR, displaying the value at the first location. So that is what you are given here. So asterisk PTR is the value at the location, PTR is the address. While PTR plus plus is going to be incrementing the pointer to the next location or incrementing the address by the next location. So here integer actually occupies 2 byte of memory. The PTR plus plus will increment 2 byte to the PTR. So automatically from this location, from this location 1 to location 2, it is going to be shifted by incrementing the PTR. So if you increment normal integer, it will increment by 1 by default. If you increment this a pointer variable based on the integer type, so 2 byte of memory is going to be incremented in PTR plus plus. That is what happening. So second, after PTR plus plus, so PTR will be here. The PTR will be the address of 2, and asterisk PTR will be the value is 2. So that's what given over here. So 2 byte of, so here depending upon the compiler, it's a 4 byte of memory actually. So 4 byte is added and the value is 2, and so on. 4 byte is added, next value, and so on so forth. So this is how pointers and arrays can be working, and also we incremented the pointer by the memory address. So that is what pointers in C++. End of the session. Thank you. Hello everyone, welcome back. The course Essentials of Object-Oriented Design and Programming. So we are in the module 1, Introduction to OOPS. In that module 1, current session we will be discussing about data types in C++, variables in C++ like static variable, constants in C++, and as well as the pointers in C++. That is what we are going to see in this session. So let's start. So data types in C++ are in 3 broad category: basic type, derived type, user-defined type. In basic type, we are having integer, character, float, double, and void. And coming to derived types, we are having pointers, functions, references, and the arrays. And in the user-defined data type, we are having a structure, class, union, enumerated, and the type definition. And coming to the variables in C++, it is the reference or identifier for a value in a memory location. That is what variables in C++. It is an identifier. Okay, so the variable name is a sequence of 1 or more letters or digits or underscore sometimes. So we are having rules for defining a variable name in C++. Variable name can have 1 or more letters, as I said in the beginning, and it should not have a white space in between. It should not have the punctuation symbols in between. Variable name must begin with a letter or a underscore. So it should not start with the number or special symbol. Variables cannot be keywords. And data C++ is a case sensitive language, so that variables must be written in capital letters, differ from the lowercase letters. Let us check the variable declaration is valid or not based on the rules as we mentioned here. So here int age is the valid declaration. Age, everything is fine. Check out this one. So character name also valid one. So number is at the end. Check out this one. Int first place is the number should not be at the beginning. It's a invalid. Check out this one, double total amount. So here there is a white space in between the identifier, total space amount. It is an invalid declaration. Either you should use underscore. Check out this one, float net hyphen worth. It is also not allowed. You should use underscore in between, not the hyphen. The last one, this one, check out int character. So the variable name should not be a keyword. So char is a keyword data type, so it is not allowed. So this also not allowed because we are having the punctuation symbol in between. Okay, so these are all some variables, valid and invalid variables in C++. So based on the scope also we are having a types of data types in C++. First one is a local variable, a variable declared within the method of a class. The scope is within the method. Static variable or class variables are variables have only one copy shared among the different objects of the class, which is declared inside the class. And the next one is the instance variable. So variable declared inside the class but outside the method. So that is what the instance variable. The constant is the value doesn't change. That is what constant. In C++, const keyword is used to make a entity as a constant. So in C++, constants are identifiers whose value doesn't change. Okay. So while the variables can change their value at any time, but the constant never change. So it is a fixed value. Say for example, pi is a fixed value 3.14159, and it can be specified by the programmer. So we are having integer, floating point, character type, string type of constant in C++. So let's see some example. So before that, we are having rules for declaring a constant. So as a variable, it should not have any special symbols in between. So written capital, no blank spaces in between. So if you use hash defined preprocessor directive constant declaration, means you should have a space between hash defined and the constant name. Let us see in the example, you'll understand clearly. So this is the common type. So constant keyword, data type, and the constant name and value is a syntax. So the example is const keyword, float is data type, and the pi is the constant whose value is 3.14. So this statement will be compiled by the compiler. Then only the pi identifier takes the constant value of 3.14. Check out this type where it is using preprocessor directive hash define pi, so it should be in a capital. The rules I said now. 3.14159 is the value. So the space between hash define and the constant identifier and the value. So this preprocessor directive doesn't need an execution. It is excluded from the execution. So this is a way of declaring a constant in C++. So some programs will attach at the end. Now let us move on to the pointers in C++. So pointer is a variable in C++ where it is holding the address of the another variable in the program. That is what the pointers. So the Y means the pointers deal with the memory addresses, which is fast and efficient. And the syntax is data type, asterisk symbol, and the identifier. Check out this example: int asterisk p comma sum. Sum is a normal variable, integer variable, and asterisk p is an integer pointer variable. To assign a value to the pointer, you should use the ampersand symbol, that is the address of another variable given to the pointer variable p. Let us see an example. We will understand clearly about what is pointer. Check out this example. Enter file, namespace std, and the main function, and inside that I'm having a variable declaration. Integer asterisk p is the pointer variable, and sum equal to 10. Sum is the integer whose value is 10. Now pointer p assignment is address of the other variable. The other variable is sum over here, so address of the sum is given to p. But this is how the pointers are dealing the other variable, address of another variable. So check out this output to see out address of ampersand sum. Ampersand sum is the address of the sum variable. Sum is the 10. So in a memory location, sum will be stored. Sum's address will be printed over here, and that is also given to p. So next statement, I'm just displaying the p in output statement. So p also same as ampersand sum. Check out the first two output 712, 712. It's a random memory address given by the compiler at the runtime. And coming to this one, ampersand p is the address of the pointer variable. So pointer variable is holding the address of another variable. That variable also having its own address in a memory. That is what ampersand p. Check out the last statement, C out asterisk p. So value at the p. Asterisk means value and p is address of sum. So in the memory address, what is the value? Asterisk at the memory address. I mean value at the memory address sum is 10. 10 will be displayed. That is what the last one. So this is how the pointer variable assignment can be done, and the the meanings of ampersand p, p, and the ampersand sum. Check out the next example. So here array is one pointer. So check out this array. Array 5 is the size of the array and whose values are initialized in the same line 1, 2, 3, 4, 5. So one pointer variable whose pointer ptr is a pointer variable. So in this assignment, check out ptr equal to, generally we used to give ampersand of the other variable. So here arr refers that the array name refers that address of the first element. That is what actually this array name represents. So address of the first element given to ptr. So now asterisk arr is going to be address of the value at the first address would be 1. So 1 is the value. And next one is arr is going to be the address of the first element. So one's address will be this one, 680. And check out this value at the ptr. Value at the ptr is value at the arr. Arr is going to be the address of the first element. So value at the first address is 1. Okay. And this one ptr is the address of the first element. What is that address of the first element? Which is arr. So this ptr will be the arr. Ptr and arr both are same. Okay, sorry. And coming to that is what happened in this statement. So check out this area. So I iterated these statements 5 times. So I'll tell you why I did it 5 times, because of the 5 elements are there now. So I'm displaying ptr and the value at the ptr. So ptr is the first address, and the value at the first address would be address of this element and the value. So address of the first element is 680 and the value is 1. Next statement, I'm incrementing ptr by 1. So pointer will be incremented to the next location. Actually what is happening is ptr is incremented 2 byte of memory location. Automatically it is pointing to the next memory location. It is not like a integer increment. It is a pointer increment, which is an integer type. So 2 byte memory will be added. So ptr will be incremented 1, so which will be pointing to the next location, and the address will be printed. So and then next third time, so ptr plus plus, so third location and the value, third location value, fourth location value, fifth location value. So 5 times the iteration is over, it is coming out of the loop. So here array and pointers are explored here. Okay, so that is the end of this session. Thank you all. Welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 1, Introduction to OOPS. In this module we discussed, in last session we discussed data types, variables, static variables, constants, and pointers. In this session we will be discussing about type conversions in C++. Let us see what is type conversion. So type conversion is in C++ is changing a variable of one type to the another type, or one data type to the another type of data in a C++. That is what type conversions. We call that as a type casting too. So while type conversion is done implicitly, casting has to be done explicitly by the programmer. So this is the hierarchy of type conversion. So where the high level is long double, the low level is short integer and character. You can type convert from character to long double, lower level to the higher level, and vice versa, or any types in between. And let us see what is implicit type conversion. So if the type conversion done automatically is called as implicit type conversion. Generally this will be done by the compiler. So this type conversion is also known as automatic type conversion. So it is done by the compiler. Let us see by the example how it is working. So in the C++ program, this is a header file and our namespace std, and in the main function we are having 2 variables. One is integer, another one is float. Integer variable is numInt and float is numFloat, and respective values are initialized. So check out the third line in this main function. So sum is a float type, sum equal to numInt plus numFloat. So in this line, the compiler will convert the num integer as a float to float, and num float is by default it is float. So float and integer to float is converted, and both are added, and the result is stored in sum. So the numInt is displayed, numFloat is displayed, and sum is summation of converted integer to float plus float is added, and the result is given over here. So this conversion is done automatically by the compiler. So such a type conversion is called as implicit type conversion. And another example of implicit type conversion. So here we are having a two variable. The variable one is integer whose value is 10. Variable two is character whose value is A, single alphabet A, single alphabet. So x equal to 10 integer, y equal to A character. So here what I'm doing is in the third line x equal to x plus y. So x value added with y value. Generally we can do arithmetic operation, addition operation with the similar type of data. So in this line what happens is the compiler will convert the variable y whose value is single character alphabet to the ASCII number. So from alphabet to ASCII number, it is automatically converted by the compiler. And for alphabet A, ASCII number is 97. So 97 plus x value is 10. So 107 will be given to x value. And in the next line, integer z. So result is integer z equal to x plus 1. Already we had x value is 107, and 107 plus 1, 108. So that is what the result shown here, right? So the variable y is a character, even though it is a character. So while doing the integer addition, automatically the compiler will convert the alphabet A into the equivalent numeric value, ASCII value 97. So this is also an example of implicit type conversion. Next we will see typecasting. So if you are doing the type conversion explicitly, we call that as a typecasting. Okay. So a typecasting is an arithmetic expression, tells the compiler to represent the value of the expression in a certain format. It is done when a value of high integer data type has been converted to the value of lower data type. So let us see with the example. So the syntax for typecasting is the destination type which you wanted to convert, and the variable which you wanted to convert should be given in a parenthesis. So the ulta is also possible. So in the destination type can be given in bracket, and the source variable name can be given without bracket. So both are allowed. So we'll take this example as it is. So check out this. So the destination type is integer, which means I wanted to convert the sal into integer type. Sal is originally float, so floating point number 10,000.00, and I'm having a income as an integer. So income is equal to typecasting int. I'm converting the salary, 10,000 into integer value. This is the typecasting. So here the inside the parenthesis variable is given. So check out this type. So this is also possible. Inside the parenthesis you can give the destination data type. So both are allowed, both are possible. Such a type of conversion is called as typecasting or explicit typecasting. Let us see in example program. So header file, namespace std for naming conflict avoidance, and main function. So I'm having a double x is the variable whose value is 5.444. So int sum is the integer variable whose value is explicitly converting x into integer, and 1 is added, or numeric integer 1 is added to this. So x value is 5.444, or integer, it is a floating point type. So this float type, higher type converted to the lower type integer, and 1 is added. So here explicitly I'm converting to the integer type and adding numeric 1 or integer 1. So the result is displayed. So this is the explicit type conversion, which is called as typecasting in C++. So with that, we are finishing the chapter. Thank you. Hello everyone. Welcome back to the course Essentials of Object-Oriented Design and Programming.
and we are in the module 1, introduction to OOPS. In this module 1, we'll be discussing the chapter conditional and looping statements in C++ and arrays in C++. So in C++, we are having four looping statement or looping structures. The first one is for loop. So we are, if you wanted to execute a set of statements fixed number of times, we can go for a for loop. And while loop also repeat the statement until the condition is true. As long as the condition is true, it is going to be repeating in the set of statements. And do while is similar to while loop, but the condition will be checked at the end. So without checking condition, it is going to be execute body once. And the last one is nested loop, where loop inside another loop. That is what nested loop. Come, let's see in detail. The first one is for loop. So for loop is entry control loop. So if the condition is true, then only it is going to be executing the set of statements inside the function, body. Okay, so initial value, so the syntax of for loop is for loop, for keyword, initialization, and the condition. As long as this condition is true, the body will be executed repeatedly, and the updation, incremental or decremented to the count. So let us see the example. Yeah, so we'll have an example to print even numbers from 1 to n using a for loop. Very simple code. Let us see that simple code. So I have a two variable, one for incrementing the value, n is going to be the upper limit. So from 1 to n, I have to print. That is what my task. So I have to read the n value from the terminal. So cout, enter the number. So user entering the number. By using cin, I read the number from the terminal. And I is initialized to 1. So this is the initial condition. Initialization, upper condition, condition, and the increment. So I equal to 1 and I less than or equal to n. So this int is not in it actually. I less than or equal to n. As long as I less than or equal to n, so the function, the body will be, the set of statements will be repeatedly executed, and the increment I value. So to find a even number, the modulus statement is actually used. So the number mod 2 if equal to 0 means that number is even number. So all the even number will be checked, only that even number will be printed. So my condition is for initial condition, initialization, the condition, and the increment. So this is how check out the syntax. So initialization, condition, and the updation. So initialization of I is 1 and the condition is I as long as I less than or equal to n. So I will be keep on incrementing. I will be checked against this condition and I will be printed. So this is the simple program. So to print even numbers. So this is the condition to print, check the even number. And if the condition is satisfied, the cout will be executed. If the condition is failed, this cout will not be executed and I will be incremented once. So then incremented I will be checked against this. So at first time I equal to 1, I less than or equal to n means, so it is going to be repeating and I will be incremented. That increment value will be checked over here. So initialization happened only once. So condition checking and the increment will be happened as long as this I less than or equal to n. Okay. So if the condition is satisfied, these two statements are executed. Okay. So that is what. And next loop is while loop. So while loop is entry controlled loop. So if the condition is true, then only the statement will be repeatedly executed. Only if the condition is true. As long as the condition is true, the statements are executed repeatedly. If the condition fails means it comes out of the loop. So that is what the while loop. Let us see the example. So the example is to print the sum of numbers from 1 to n using while loop. The same program slightly modified. So sum of n number. So I have to sum every number from 1 to n. So initial value will be 1 and upper highest value will be n. So your number has to traverse till n. So let us see the example program. So I initialized I as 1 and the n is the upper limit and sum is initialized to 0 because every time I will be adding sum to old sum. And I get the number from the terminal. So cin n. So n is read from the terminal. As long as I less than or equal to n, I keep adding the sum with the old sum. So sum will be added every time, right? So sum will be added with the old sum. So initially I equal to 1, sum will be 0, 0 plus 1. So I is incremented. I will be 2 now. So 2 less than equal to n, yes. So some old sum plus I value is 2 now. So old sum, next time I value will be 3. As long as I less than or equal to n, for example I equal to 10 in the sense, so when I reaches 10, so sum equal to sum, old sum plus 10 will be added, and next time I will be 11, I plus plus I will be 11, so this condition will be failed. I'll be coming out of the loop and displaying the sum of the n number is sum. Okay, so initialization is happens here, and n is the upper limit and sum is initialized to 0, and I read the value from terminal, so I put the initial condition. So as long as the condition is true, then only these two statements are executed. So as long as I less than or equal to n, I keep on adding sum equal to sum plus I. So old sum is added with the I, and I will be incremented. Okay, so this is the simple while loop. And next loop is do while loop. So do while loop is similar to while loop only, but the condition will be checked at the end. So at the first time, it doesn't check any condition. It simply execute the uh, body of the loop without checking any condition. After the first time, so it is checking the condition. If the condition is true, then only it is going to be entering inside the loop again. Otherwise, if the condition is failed, means it is going to be exiting the loop, exiting the structure. So I can say without checking condition, the loop can be executed once. So while coming for second time, if the condition is true, it is going to be repeating the second time, a second time or n number of times depending upon the condition. Right. So let us check the example for the do while loop. I'll be checking the same while loop program, printing on 1 to n numbers using do while. So the logic is very simple. The condition, so you have to execute the loop body without checking condition. At first time, it is going to be executing without checking condition. At second time, if I less than or equal to 10 n, so it is going to be repeating. Otherwise, if the condition failed, I mean it is coming out of the loop. So I is initialized to 1 and n is going to be the number, upper limit number or highest number. So I read the value, I mean by using cout, by cin, I read the number from the terminal user, and I is initialized to 1. So first time I will be displayed, 1 will be printed, and second, and I will be incremented. No, I will be 2. So I will be 2 now, 2 less than or equal to 10, for example. So if it is yes true, means it is displaying I value 2. So it is going till 10. So whenever I, for example, n is going to be 10, means when I gets 11, so at that time it is coming out of the loop, it won't go inside the loop. So this is what the do while loop. So on while loop, we are checking the condition, and then only it is allowing to enter inside the loop body. But in while loop, so without checking condition, first time it is entering the body without checking condition, and second time only it is going to be checking the condition. So it is exit controlled loop. That while loop is entry controlled loop. So let's move on to next loop. So nesting of loop. So here loop inside another loop. You can use either for loop or while loop together, or for inside while or while inside for, whatever it is. But the logic is we'll be having a loop inside another loop. So here I used two for loops. So for loop inside another for loop. So this pink color is actually inner loop. I just given in a syntax only. So this is inner loop. So this is going to be repeated this many number of times. Outer number, for example, outer loop is happening some 10 times in the sense, so 10 times this inner loop is going to be executed. So coming to this inner loop, again depending upon the condition, it is going to be repeated n number of times. So totally m into n. For example, outer loop is m time repeated, means inner loop n time, means so m into n number of times the statements are going to be repeated. So this is what nesting loop. Let us see a simple example for this nesting loop. Check out this program. So here I'm having just for demonstrating how the nesting loops are there. So this is outer for loop. In the outer for loop, for example, I'll be iterating for I equal to 1, 2, 3. So I will be iterating to 1, 2 up to 3. So 3 times the loop, outer loop is going to be iterated. For every I value of 1, 2, 3, the inner loop will be executed. So inner loop will be I equal to 1 and 2. So it is going to be repeating 2 times. So if you apply the logic, you can use it for matrices, rows and columns. So the outer loop can be used for row, and inner loop can be used for column. For each row, we'll be having this many columns. Okay. For row 1, we are having 2 columns. Row 2, we are having 2 columns. Row 3, we are having 3 columns. So 2 columns. So 3 by 2, 3 rows and 2 columns. In such cases, matrix manipulation or matrix reading and processing, you can go for the nested loops where you can read the rows and columns and you can use it. So that is about the 4 types of loops in statements in C++. And check out this code. Can you guess what will be the output of this code snippet? So I'm having iostream header file, name std, and main function. Inside the main function, for loop, there is no initial condition, no initialization, no upper condition, no increment or decrement. Simply 2 semicolon and 1 cout statement. So you can try in any compiler and you can check out what will be the output. Yes, the output will be, this for loop will be iterating infinite number of times. So it doesn't have any initialization, it doesn't have any upper condition. So there is no condition means it is keep on iterating the statement, or the loop body will be repeated infinite number of times. That is the output of this code. So this, what will be the output of the code, will be printed to the output screen infinite number of times. If you want, you can check out any in your online compiler or in your compiler, C++ compiler. Okay. Next, we'll move on to the conditional statements in C++. So conditional means based on the condition, the program flow will be decided, or we can call this as a decision making statements. So here in C++, we are having 4 possible decision making statements. First one is simple if, second one is if else statement, and third is if else ladder, and the last one is switch case statement. So let us see one by one. First one is if statement. So if the condition is true, so execute the statement, execute the set of statements. So simple if, we call that a simple if. So if the condition is true, the set of statements will inside the bracket will be executed. Otherwise, if the condition is failed, it never executed. Very simple. Let us see the, yeah, we can go for the next one. So if else statement. So if we are having the else part, which means if the condition is true, this part will be executed. Otherwise, if the condition is failed, so the else part will be executed. So that is what if else. So else is the keyword, if is the keyword, condition will be any condition. If the condition returns true, boolean true, means the first set of statement will be executed. If the condition failed means, so the second else block will be executed. Okay, so for this you can try out check a number, given number odd or even. So inside the condition you can write if the number n modulus 2 equal to 0 means it's odd, you can print the number in odd, else even. So that is what the, so you can put a condition in over here. So if the condition is satisfied means you can print whatever you want to do, the condition is true. Otherwise the else part you can print it. Simple program for printing a number odd or even. So next one is if else ladder. So for example, if you wanted to check out the multiple if condition, else condition, and again if condition, else condition, so the suitable one is if else ladder. So we'll be having, if the condition is true, go for the else part. In else part also again you can check a condition, and if that condition fails, you can go for the another if condition or else part. So that is what if else ladder. You can include as many as if else if in a multiple condition checking. So that is what the if else if ladder. So here I used only one else if. Like this you can include as many as else if you want, depending upon the conditions. For example, I have a 3 scenario. So condition 1 is one scenario, condition 2 is another scenario. If both the conditions are failed, I can go for the third scenario. So that is what actually the logic. So if the condition 1 is true, this statement will be executed, or this set of statements will be executed. The rest 2 will be never executed. So if the condition 1 failed, I'll be checking condition 2. If the condition 1 failed, I'm going for else part, but in else part I need to check a condition. So if the condition 2 is true, this set of statements will be executed, right? So if both the condition failed means this else part will be executed. I'm repeating, if the first condition true means this statement will be executed. If the first condition failed means I'll be checking the second condition. If the second condition true means this statement will be executed, the rest two will be ignored. The both the conditions, so second also failed means I'll be coming to the else part. So like this you can add as many as else if depending upon your need. So this is what if else ladder. So the perfect example for this one is finding a greatest of three numbers, right? So finding you can try in your mission, or I can give in assignments, you can furnish the assignment. So I'll be hinting the answer. So if the condition one is we'll be having three numbers assuming a b c. So if the in the condition one, if a is greater than b and c, a is greater. Else if b is greater than a and c, b is greater. If the both the condition fails, a also not greater, b also not greater, and c will be the greater. So you can club the two conditions in a here, condition 1 and 2. So if the both the condition fails, now definitely the third number will be greater. So that is what greatest of three numbers, if else ladder. So next is switch case statement. So if in such situations I wanted to give the menu based condition. So if else ladder is somewhat confusing, I can go for the menu. If you choose option 1, you can go for the this one. If you choose option 2, you can go for this one. Otherwise, you can go for the default option. So like this, I wanted to display a menu based driven scenario. So the suitable one is switch case statement. So multiple options will be available. User has to select any one. So in that case, you can go for switch case. So switch the option. Expression is option. So if the option value is 1 means, so this statement will be executed and the break will be exiting the switch statement. And break statement should be mandatory in every cases because it has to come out of the entire switch case. That is what the use of the break statement. If the expression is value 2 means, this data statements will be executed and so on so forth. If none of the expression is meet this value or giving this any of the value means default code will be executed or this default case will be executed. So multiple options will be there. So from that you can check out. So the assignments which I can give you is write a C+ program to check whether the given input is a vowel or constant using switch case. You can read the single character from the terminal and you can match with the vowel means A, E, I, O, U, else the consonant. So 5 options A, I, E, I, O, U, 5 options. The default will be consonant. Any of the character which doesn't meet with A, E, I, O, U, so by default it's going to be consonant. So that is what the simple program, you can try it in your local machine. And that is what about the conditional statements in C++. So next we'll move on to the arrays. So arrays is an important topic in C++ or any programming language where similar data items are grouped together in a common name. These data items are stored in a contiguous memory location or continuous memory allocation in locations. So it allows the multiple values can be stored in a single name and we can access by the index number. So index value. So that is what the arrays. And the array index start from 0. So let us show the example, we'll understand easily. Your syntax for the array will be this one. So data type, the array name, and in a square bracket you have to mention the size of the array. So example would be int is my data type and ARR is my array name and 6 is going to be my size. So totally 6 integer elements are stored one after another. So we can call that in a single name called ARR. So that is what the array. So see this picture, I think you can understand. So the array size is actually 6 over here. So 0, 1, 2, 3, 4, 5, 6 are the indexes, or I can say memory locations. So these are all the one. For example, if it's integer means integer location 1, location 2, and so on so forth. So this first element can be referred as 0. If the array name is ARR means ARR of 0 is representing the first number, first value. ARR 6 would be, and this won't be ARR 6. Actually, the error of actually here we are having 7 elements actually, but in example I given only 6 elements. So this is going to be the last element, ARR of 6, which is going to be the 7th element in this array. So it's very simple. The elements are stored contiguous memory location and will be referred by the indexes. And this with the index again, access the array elements. So all these data are similar type or common type, similar type. Okay, so let us see how to initialize the array. So initialization means you can assign a value to the array. So the two ways are possible. The first one is this one, array name is ARR, size is 5. So with the curly bracket, I can initialize the value. So 10 with the comma separation. So 10, comma 20, comma 30, comma 40, comma 50. So this is how you can initialize. You can mention the size, declaring the array, mention the size, and this assignment operator is going to be assigning or initializing these values to the array. So check out this last one. So this also correct. So without specifying the size, you can give the values over there. So automatically the array size would be 5. So it is optional. You can mention or else you can give it as an empty. So in both the examples, you have to use a curly bracket and comma separator between the elements, and these are all the elements are initialized to the array called ARR. Okay. So here ARR of 0 would be the first element. ARR 4 will be the last element. So starting from 0, 1, 2, 3, 4 are the indexes or memory locations. So accessing the array elements. So my array name is ARR. So I initialized with this initialization. So while I'm trying to, ARR of 3 would be the fourth index value, 0, 1, 2, 3. So this ARR of 3 will be 40. 40 is the value, and this is going to be this. In this way, you can access the element. So starting from 0 to n minus 1. So where n is going to be the size of the array. So we are having three types of arrays in C++: one-dimensional array, two-dimensional, and three-dimensional array. So let us see one by one. One-dimensional array is going to be a sequence of elements in one name. So this is what we discussed in the beginning, one-dimensional array. So this is the example of one-dimensional array. Only in a row, a sequence of elements in a row, single row is called as one-dimensional array. So the example is, the syntax is same. So array name, data type, array name, and the size. So integer is data type and array name, and you can initialize, or later you can initialize. So check out this example. This is the good example for one-dimensional array, which is given in the beginning. So where array size is 7 actually. So starting from index 0 to 6. So total 7 is going to be the size of the array. So this single row is called as one-dimensional array. So A of 0 will be 10, A of 1 will be 25, A of 3, A of 4, A of 4, A of 5, A of 6 will be the seventh element in the array or last element in the array. So these elements are stored in a contiguous memory locations. So next would be, you can try to read and display one-dimensional array by using nested loop. Okay, either you can use two for loop or two while loop. So inside the loop, you can see out, ask the user to enter the value. By using cin, you can read the array element. So next is a two-dimensional array. So here two-dimensional array will be having a row and column. It is a kind of matrix where we'll be having a row and column. You have to mention the how many rows and how many columns in a two successive square brackets. So the syntax would be the data type, array name, and row size and column size in a example would be integer data type and array name is ARR. So 2 rows and 3 columns. So 2 rows and 3 columns. This is the initialization of 2 rows and 3 columns. I'll show you in the picture. Check out this. So where we are having 3 by 3 array. So 3 rows and 3 columns. So this would be array of 0, 0. 0th row and 0th column. 0, 1, 0, 2, 0, 3, which means fourth element, fourth column. So this one will be 1, 0, 1, 1, 1, 2, 1, 3, and so on and so forth. So it's literally a matrix. So you can declare a matrix in C++ by using two-dimensional array. Okay. So here also you can use a nested for loop and declare a two-dimensional array. You can read the value from the terminal and display the 2D array by using nested for loop or nested while loop. So try the program in your local machine. I also give that program in assignment or the material at the end of the chapter. So next one is three-dimensional array. So we'll be having a stack of 2D arrays forming rows and columns with the several layers. Rows and columns in the several layers. So each element is accessed by using 3 indices, one for layer, another two will be row and column. So the example would be this one. So data type, array name, layer 1, row and column. So 2 layers, row and column. So how can say 3-dimensional array would be have you seen bricks for construction site? They'll be arranging in rows and columns in several layers. That is a good example of 3-dimensional arrays. I'll show in the picture. Yeah, check out this. So here, this depth is actually layer 1, layer 2, layer 3, and so on and so forth. And row 0, row 1, row 2, and column would be column 1, column 2, column 3, column 4. So 4 column, 3 rows, 3 layers. Okay, so 3 layers. So layers is a depth actually. So bricks can be arranged in a construction site like this now. So that is a good example of 3-dimensional array. So for this also you can use this kind of layer number, row number, and column number. So which representing the element. So for example, element at this location, this first one I can say layer 0, row 0, column 0. Maybe the hidden numbers is not visible to the user actually, but from visible number I can say for this one is layer 0, row 2, column 3. This one a of 0, 2, and 3. So 3 is the column and 2 is the row. 2 means 0, 1, 2, third row, and fourth column, 0th layer. So I'll give the materials, codings for demonstrating 1-dimensional, 2-dimensional, and 3-dimensional array in separate material at the end of the chapter. You can refer that. And if you have any doubt, you can contact me. So that is what arrays in C++. So with that, we are ending this chapter. Hi everyone, welcome to the course Essentials of Object-Oriented Design and Programming. So we are in the module 1. Last session we were discussed about conditional looping statements in C++ and arrays in C++. And in this session we will be seeing about classes, objects, abstraction, encapsulation in C++ or using C++. Let us start. So so the class, object, abstraction, encapsulation are the concepts of the OODP. So in that, object is a real world entity, represent any real world object which is called as object. It is having a state and behavior. The other word, the object can be instantiated from the class, or it is called as instance of a class. And in other words, I can say object is a runtime entity. So any real world entity, runtime entity, it is having state and behavior. It is an instance of a class. So these are all the definitions or points about the object. So you can take any real world items like a pen, book, chair, table, anything. So we can represent in a programming, but each object having its own functionality and the state. So that is what state and behavior. Behavior is a function, state is a property. So an object is having a state, behavior, identity. State means the value or represents the data of an object. This is called a state. Behavior means functionality. So for example, pen is used to write. So writing is the functionality of the pen. And identity means it's a unique ID to the object, which is called as identity. So it is not visible to the user, but it is used by the internal machines or internal reference. That is what identity. Generally, I can say object is having state and behavior. It is an instance of a class. State means data and the behavior means functions. And coming to class, so class is the collection of objects, or else that it's a blueprint for creating objects. That is what class. Or using class, you can create object. Okay, so class is having set of properties and methods, so which are all shared by the all the objects of the same class. For example, if you take your classroom, if you are having some 60 students, 60 students I can equate as object. All the 60 students are able to access the properties of the classroom, like a blackboard or chair, table, fan in a classroom are shared among the all the objects. So class is the specification or a template for an object. Okay, a class contains data, method, constructor, classes, and interfaces. In a class, I may have interfaces and classes, constructors sometime, and most probably will be having data and the function in a class. Okay, and let us check the animal class and real-time example. So if you take animal class, um, many animals like elephants, giraffe, zebra, lion are belong to the animal class, and each of the object is having its own state and behavior. For example, if you take any animal is as an object, it is having its own property, like what breed it is, and the color, complexion, and the behavior, I mean habits or eating habits. So these are all the state. Behavior means how it reacts, how it acts, hunting behavior, sleeping behavior, or roar, something like that. So this is we can relate the animals, group of animals as a class, and in that each of that is a one object. And same way, I can say vehicle class, which is having several type of vehicles like car, bike, truck, or bus. So each object or each item is having its own state and behavior. So how it what is the color, model, etc. of each object, and behavior like how it is functioning, I mean how it is gear is working, engine is performing, and how what is the mileage of the each vehicle. So like this the behavior can change, can differs. So this is the simple real world example of how the vehicles are grouped by one class, and in a class we are having a separate vehicle as a one object. And moving on to the simple example of class. So this is the header file for C++ and the naming conflict avoidance statement using namespace std to avoid the naming conflict. And the syntax for defining a class is class keyword and the class name. And my class name is student. And inside that we are having member ended data and functions, are member data and member function inside the class. So these are all the member data are datas, and I'm having one function which is called as total. So the class is a bundle of data and function. What is inside a function? Function is having a set of statements in a grouped in a bundle. Okay, so my function name is total, and I'm having these are all my data. Register number is integer, name is character, group of characters, character array, and these are all the three marks as an integer. So these are all my data, and I'm having a function total. So this is the end of the class. So end of the function and end of the class with the semicolon. So every class must be enclosed with the curly open close bracket and ended with semicolon. So that is the end of the class. In a main function, so to create an object, I told you, right? So object is an instance of a class, or by using class you can create as many as object as you want. Say for example, here my class name is student. To create an object for student class, so class name space and valid identifier object name. So S1 is the object. So with that, S1 object is created from the student class. So by instantiating an object for a class, our student is the blueprint for creating this object S1. So with that object, I can access the members of the class. What all the members? Member data and function. Okay, so here I'm just calling the function object dot method. So method is total, so I'm calling the method function, method or function. So this object S1. So here I created only one student. So like this, you can create as many as student object as you want. Say for example, I told you, right, 60 students in a class. You can create 60 objects like this: S1, S2, S3, S4, up to S60. For all the 60 objects, so these are all the common shared right, shared entities. So for defining a class, so class keyword, class name, curly open and close bracket with semicolon inside the class. This is the access mode. Let me discuss in after this topic. Next topic we'll discuss about access specifier in class. So inside the class, I'm having a member data and the function bundled together. For creating object, class name space a valid identifier is a syntax for creating an object, and object dot the member function. You can access the register number, you can access the name, you can access the marks of M1, M2, M3, anything with the dot operator. S1 dot register number, S1 dot name, S1 dot M1, S1 dot M2, S1 dot M3 also allowed. But these three variables are placed inside the function. I'm just calling the total function S1 dot total, which is going to call the total function. So that is the example of class creation in C++. And let us see abstraction. So already in the beginning of the class, we were discussed the OOPS introduction. Abstraction means hiding the implementation and showing the essential details to the customer, to the user. That is what abstraction. So identifying only the required characteristics and of object and ignoring the unwanted details. That is what the aim of the abstraction. So let us see, the other name for abstraction is information hiding or data abstraction. So hiding the implementation and displaying the necessary details to the user. Okay, so the real world example for abstraction is, for to drive a car, person need not know about how the car is functioning, so how the engine is running, how the brake is applied. So the basic thing is how to put a gear, how to release the clutch, and how to drive a car with the steering wheel. So this is what every driving person needed, but need not to know how the gear works with the engine, how the engine is performing, propelling, all these and all not needed. So the implementation details not needed. The basic details like a steering wheel, a brake, clutch, and the driving the car, basic buttons are sufficient to drive a car. Okay, and encapsulation. So already we discussed encapsulation means encapsulating data and the function together, or encapsulating variables and methods. Already in this, just now we saw the example. In a class we are having member data and member function. So we are bounding or wrapping variables and methods inside the class. So that itself encapsulation. Okay, so encapsulation by achieved can by declaring a variables in a private access mode. So there are three access modes in C++: private, public, and protected. So let us discuss about the access specifier in next session. So as of now, if you declare the variables as a private and the methods in public, so that is providing the encapsulation inside the class. Okay, so let us see the example. So abstraction means hiding the implementation, displaying only necessary details. Encapsulation means bounding the data inside the class, private data and public method. That is what encapsulation actually in simple words. So check out this class name is student. So this is the public access specifier, which means all the member data and member function after this public declaration will be available outside the class. So it is public it is declared as a public, means it can be available outside the class, but only for the object of the class. Okay, so this is the same example just now we discussed. So two marks M1 M2 are the integer, and one get method. So read the M1 and M2 and displaying the M1 M2 marks. That's it. Okay, end of the class, and I'm creating the object. S is the object. So by dot operator, I'm calling the method get and display. S dot get, S dot display to call the methods inside the class. So here the point is, so I'm just wrapping up the data and function together. Encapsulation is achieved, and I'm not showing what is happening inside a get and what is happening inside a display function to the any object happening, any object of the class student. So it doesn't know what is inside the get function, what is inside the display function, but it knows S dot get is going to read the value, S dot display is going to display the value. That's it. So yes is object s doesn't know what is implemented inside get and display. Hence abstraction also achieved. So encapsulation and abstraction is achieved together here. So here the member data and member function are in a public. Check out this program. The same program is slightly modified. What I did is here I made the member data in a private, functions in public, which means so the private data members will not be allowed to access outside the class. So here the class ends. The class name is student, private M1 and M2, and public get and display method. Same program, so which we discussed in the previous same program. I'm slightly modifying the access mode of M1 and M2 in a private, and get and display in a as it is in a public, which means but even though S is the object of the class, S cannot access the private members outside the class. If you try to access s.m1, s.m2 outside the class, it throw an error because it is declared in a private. But inside the class, get and display can access the members m1, m2 inside the class. See, this m1 and m2 are used inside get function. Get function is inside the class only. Similarly, display function is using m1 and m2, but it is but the display function also inside the class. So if you try to access the private members outside the class, it will throw an error. So it is also comes under the encapsulation. But check out this s dot display and s dot get. So these are all declared in public and be accessed outside the class. Okay. So abstraction encapsulation achieved here. And here I made everything in the public. So M1, M2 public, the data and function, everything in the public. So outside the class, I can access get data, display, s.m1, everything is allowed. So this is a kind of uh, not abstraction encapsulation. It's also binding the data and function together. That's an encapsulation. So it doesn't throw any error. Okay. So that is what the so if you made this is a private M1 and M2, it definitely will throw an error. But I'm not accessing the M1 and M2 outside the class. So check out this code. So though it is declared as a private, so I'm not accessing outside the class. S dot if I access S dot M1, definitely will throw an error. But I'm using M1 and M2 inside the class. So inside the class, I'm using the private data members, doesn't throw an error. So hence abstraction encapsulation is achieved here. So the advantages of encapsulations are it is very secure, data hiding is supported, and increased flexibility, and we can reuse the code, and testing the code also very easy. So that's all end of this chapter. Hi everyone, welcome back to the course Essentials of Object Oriented Design and Programming. So we are in the module 1, Introduction to OODP. So in this module, we will be discussing, in this session, we will be discussing about access specifiers in C++. And last session, we were discussed about the classes, objects, and simple program by using classes, how to create object, and how the abstraction encapsulation are achieved by using classes and objects. That's what we discussed in the last session. And now we're going to see access specifiers in C++. So in C++, we are having three access specifiers. One is public, private, and protected. So access specifiers are setting the boundary or giving the scope of the members. So if you declare a public, it is available to everyone in the class. So it is available outside the class too. That is what public. And private means which is not used, allowed to access outside the class. The scope is within the class. Protected means it can be used outside the class only in the case of inheritance. So these are all the three access specifiers or access modifiers in the C++. Let us see one by one. Public access outside the class, private is within the class, and the protected is in the inheritance. Okay, yeah. So check out this example. So class name is student, class keyword, and the class name is student, and the curly open and close bracket end of the class. So here public followed by the colon. So public is the keyword, access specifier. So following members integer x and the void display function, member data and member functions are declared as a public, which means even outside the class, the integer x and void display can be accessible for the members of the class. So that is what the public access mode or public access specifier or access modifier. Okay. And check out private. So within the class only it is allowed to access. Outside the class, no one able to access the members of the class. If you try to access it, throw an error. Okay. So by default, if you didn't specify what kind of access mode, access specifier for any member data and member function in a class, by default it is taken as a private, which means, so here I declare as a public, right? So if you fail to use this public, I mean declare as a public, so by default it is taken as a private. So let us show in this example. Yeah. So so here so here I declared this integer x as a public. So if I miss this statement, by default this x would be a private member. Okay, that is what they say. So by default the member functions are private. So if you are not declaring anything public or protected or private, so by default it is taken as a private. So third access mode is specifier is protected. So it is similar to private only within the class only, but it is used only in the case of inheritance. So in a subclass only the members are allowed to access, so not outside the class. Okay. For example, if you're having a class A and class B, class A is inherited to class B. So if you declare any member data inside the class as a protected, only that can be act as a private members of class B. So that is what the use of protected member. And check out the simple code. My class name is test and open and close end of the class. I'm having a two access type. One is public integer x and a private integer y. So integer x is available to all the members of, I mean, outside the class, to all the members of the, I mean, all the objects of the class test. So here this is the end of the class. So outside the class, I'm creating an object for test class. So class namespace identifier is called used to create an object. So t dot x is allowed because it is a public. So outside the class, it is allowed to access. If you assign a value to 25 to x, so for the object t, x would be 25. And if you try to access t dot y, since it is a private, outside the class, it is not allowed to access. It will throw an error. So t dot y is access violation since it's a private. Okay, so this code snippet shows how the public and private is actually working. And a simple example by using a student class, how the public members will work. So my class name is student. I'm defining the class. This is the end of the class. So inside the class, I'm having integer age is the member data, display age is the member function. So both are in a public access mode. So outside the class, it is allowed to access. Okay. So both data and function both are public access mode. In a main function, I'm creating the object obj1 is the object of the student class. So I can access the obj.age is allowed because it is public, right? So I'm entering the age, asking the user to enter the age. Obj.age is initialized here, and thereafter I'm calling the obj.display. So both age, I mean member data variable and function method display age, both are in a public access mode, so that outside the class, so class scope ends here. So outside the class, the object of the class can access the members. So that is what here public access specifier example shows how the public members are accessed outside the class. So next one, check out, this is the same example, a slightly modified the age as a private, integer age member data as a private access mode. So outside the class, the age will not be allowed to access. So in the previous program, check out age is in the public. So outside the class, by using the object, I'm just initializing the value for the age. But in this code, I made this integer age in a private access mode, which means within the class only it is allowed to access. Outside the class, if you try to access the obj.age, it will throw an compilation error, a compile time error. Okay, so I'm having a function, so we're having one parameter over there. So that parameter used to assign the value for age. Okay, so So that is the end of the class. So the function display age is having one parameter. That parameter is used to initialize the age, uh, which is the private member. So check out, the age is the private member which is used within the class, which is accessed within the class. It doesn't throw any error because age is a private member. So it is used within the class. It is legible. Okay. So end of the class. And coming to main function, I'm creating the object. So object obj1. So obj1 dot age, since it's a private, it will throw an error. This statement will throw an error. So I'm getting the age input from the terminal, I mean from the user. I'm calling the display age function and passing the number, the age. So that age will be given to A will be given to age. So for the obj1, age will be initialized and that will be displayed. Okay, very simple. I made this age as a private, which is not allowed to access outside the class, but within the class, we can access it. So next one is protected. Actually, after discussing the inheritance only, you will be able to understand how it is working. But we'll be discussing inheritance in the third module only. But as of now, just have how it is working. So elaborately, we'll be discussing the inheritance in the third module. Okay, so first class name is student. Student is having only one member, which is protected. Okay. Second class is data. So this is actually inheritance. So I'm inheriting the student class to data class. Student is the base class, data is the derived class. So this is the line of inheritance. So class data colon in a public mode, I'm inheriting the student class, which means all the members of the class are inherited as it is to the child class data, which means public means, so here in a public, here it is public now, here also public. So here it is private means it is never inherited. If it is protected means it is acting as a private in the derived class. Okay. So in the public access mode, display age is a function. So it is getting one integer that will be assigned to age. So age is the private protected member of the student, and while inheriting, this age will be the private member of the data class. Remember, so the protected will be converted to the private while inheriting like this. Okay, so end of the class. So coming to main function, I'm creating the object for the data class. So because this student class is inherited to the data class, right? It is enough to create only the object for the data class. So data class object is child. So child dot age will not be allowed because it is protected. So child dot display is the legible one. So I'm calling the display function. So I'm passing one integer over there. So that integer will be given to A will be given to age. So for child class, age will be initialized. So here the point is, so while inheriting, the protected member will be acting as a private member of the data class or child class. So this is how the public private protected simply explained with the example. So next is methods. So methods is limit functions. So functions inside the class, in a class, how it is defined. So we can define a function inside the class or outside the class. If you're defining a function inside the class, you can define as it is, no issues. If you're defining the function outside the class, you can use the scope resolution operator. So let us see how it is there. So my class name is student. And in public access mode, I'm having a 2 member data and 1 member function. So void get is member function. I'm defining the function inside the class. So end of the class, see, check out, this is the end of the class. So inside the class, I'm having a 2 member data and 1 member function is defined. Okay, check out this. I declared only the function, but I'm defining the function outside the class. Okay, so I declared the function void display inside the class, and outside the class I'm defining. So to define a function outside the class, so you have to insert the class name in between the void and display. So void display in function name. So in between you have to insert the what is the class name, and this double colon is the scope resolution operator, which says that this display function is belong to student class. That is what scope resolution operator says that, and definition of the function. So here this get function is defined within the class, no scope resolution operator in between. But if you're defining the function outside the class, now I have to declare the function in the class, and this is the declaration actually. While defining that, I have to insert this class name and scope resolution in between void and display. That's it. And in the main function, you can create an object as it is, and you can call the get method and the display method as it is. Object dot the method name, object dot the method name. Okay, so I'm repeating. The function is defined inside the class, no scope resolution operator. just as it is, you define a function. And to define a function outside the class, you have to declare the function inside the class, and while definition, you have to insert the class name and scope resolution in between the return type and the function name. Okay, and you can define the function as it is, as you want. And in a main function, you can create the object, and you can call the member function by the dot operator. Object dot function name, object dot the function name. So this is how the methods can be defined within the class or outside the class. Okay, that's all. End of this chapter.
Hi everyone, so welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 1, so Introduction to OOPS. So in this session, we will be discussing about UML diagrams, introduction, and the use case diagram. So there are several diagrams in UML diagram. So in that first one is actually use case diagram. So let's start. So what is UML diagram? So it is not a programming language, it is a visual language used to represent the behavior and the structure of the software system. Generally, it helps for software engineers, businessmen, and system architect with modeling and design and analysis. So the object management group adopted the UML as a standard in 1997. So the ISO published the UML as an approved standard in 2005. So UML class diagram is a graphical notation used to construct, visualize the object-oriented system. So we are having several diagrams: class diagram, use case, collaboration, communication, etc. So in that, first one is actually use case and the class diagram. So generally, the class actually represented as collection of variables and methods, right? So here also in the class diagram, we are having variables and methods. So let us see the broad category of the UML diagram. So based on the structural, the UML diagrams are classified as class diagram, component diagram, deployment, object diagram, composite structure diagram, and package diagram. So based on the behavioral, activity, state machine, use case diagram, and interaction diagram, and based on the interaction, communication diagram, sequence diagram, interaction overview diagram, and timing diagram. So this is the broad category of the UML diagrams. So in this session, we'll be seeing use case diagram, and next session we'll be discussing class diagram. So in the module 1, we are discussing the use case diagram and class diagram. In this session, we are seeing use case diagram. So let's see what is use case diagram. Use case diagrams are used to represent the context of the system. So and functionality is offered by the software system. So what it is and what it is used for, and its working. So that is what given by the use case diagram. Or generally, users can interact with the system. So what are all the ways user can utilize the system? That is what actually use case diagram. So the who or what interacts with the system. That's what the use case diagram. So they show what the outside world is actually the system to do. Okay, so here we are having some notations for drawing use case diagram. The first one is actor. Actor is actually person or entities who is going to interact with the system. That is what the actor. Actors is actually a user or client or end user who is using the system. That is what, for example, in hydroponic example, gardener is an actor, or in agriculture system, a farmer is an actor. Okay, so so check out this example. It's a hydroponic example. So here we are having actors, gardener, nutritionist, and the plant analyst are the actors. So they are the users utilizing or interacting with the system. The system is actually the example of hydroponic system. The main aim is maintaining the plants and maintaining the storage tanks in the plants. So that is what actually. So here the gardener, nutritioner, and the plant analyst are the actors. Okay, so these lines are the use cases, how they are utilizing or interacting with the various tasks of the system. So that is what I told you, right? So maintain the storage tank. So what actor have to examine so various conditions and have to note the report and do the actions and so on. So here the flow, step by step operations to carry out, to maintain, to do some task as given as a procedures. So same way we can take this experience to implement any software system. And in a use case diagram, the important part is relationship. So how the entities are related to each other. So we are having two relationships. One is include and the extend. So first one is actually include relationship. So it's in the hydroponic system, check out this include relationship where the view report is actually including the maintain storage task. So which is actually done by the gardener. And the view report system also include the update crop encyclopedia. So which is the role is played by the nutritionist and the plant analyst. They are updating the crop encyclopedia. So these two entities are included to generate the view report. So view report can be accessed by gardener, nutritionist as well as the plant analyst. So during the analysis, the nutritionist actors actually use case will have to see what is happening in the crop encyclopedia. So the nutritionist can invoke the view reports, the use case. Similarly, gardener also can invoke the view reports, and as well as gardener is actually invoking the maintain storage task tank and as well as the manage the garden. So these are all the tasks performed by the gardener. And coming to the include relationship, so here the update crop encyclopedia use case includes the view reports use case. This means view reports is actually executed. The update crop encyclopedia is also executed. So update crop encyclopedia would not be considered as a complete without view reports. So that is what. Right. So include is, I mean, view report is actually includes the update crop encyclopedia and as well as the maintain storage tank. So these are all the interactions. I mean, yeah, users are using or utilizing the systems. So and the tasks performed are given in this. Uh, these are all the entities where tasks can be performed and performed by the actors. So actors performing view reports or invoking view report. So the nutritionist can invoke view report and gardener can also invoke the view report, and as well as plant analyst can also invoke. These are all the actions invoke the view report. So that is what this into relationship. So second one is extend relationship. So extend relationship is in this example, you can check out the include already we discussed. So nutritionist is actually doing a task of view reports, invoking view reports, and updating crop encyclopedia. And gardener is actually manage the garden as a whole task and maintain the storage tanks and as well as invoking the view report. And plant analysts can invoke the view report, update crop encyclopedia, and as well as the manage the growing plant. So this is what the task performed by the each actors in this system. So here the view report is actually extends the managed garden. For example, for managing the garden, from the report I may go for the plan of extending the what are all the points to be added while managing the garden. So this could be done by view report use case. So however, the view reports is not required when a managed garden is run and the managed garden is complete in and of itself. So we modify the use case diagram to indicate the view reports use case extends the managed garden use case. So use case diagrams gives us the capacity. So that is what the extends relationship. So, so with that we can conclude what is use case. So use case diagrams gives us the capability. So it is used to depict the context of system to be built and the functionality offered by the system. and they depict who or what interacts with the system. So the actors actually interact with the system. So they show what the outside world actually wants from the system to do. So that is what the use case diagram. So the first diagram in the UML diagram. So that's all. End of the chapter. See you in the next class. Hi everyone. So welcome back to the course Essentials of Object-Oriented Design and the Programming. So we are in the module 1, Introduction to OOPS. So in this session we will be discussing about UML class diagram. I think the last session we discussed what is UML diagrams. It is a visual representation of the software system. So it gives us the behavior and the structure of the software system, generally used by the software developers for architect for designing a software. So these are all the various types of UML diagram. And in that we started discussing use case diagram in the last session. Now we are getting into the UML class diagram. So UML class diagram is actually graphical notation, visual notation used to construct and visualize the object-oriented programming and system. So here, the class diagram describes the structure of the software system. So like class name, attributes, functions are there in the class name, there in the UML class diagram. So this is the simple syntax for the drawing the UML class diagram. So it is in a rectangular box, 3 sections. The first one is class name, second part is attributes, they are variables, and third one is functions or operations. So that is what the class diagram is actually. So let us see the parts of class diagram. So upper section, name of the class, and middle is attributes, variables of the class, and bottom is the operations or methods of the class, or how the objects are interact with the attributes of the class is defined in the bottom section. So this is the clear picture of UML class diagram. The rectangular box, top section is a class name of the class, and the middle is attributes or variables, and the bottom is the operations or functions of the class. Okay, so it is an example of a class diagram where student is the class name, the middle part is attributes. So attributes are name, address, birth date, age, register number, are the attributes. These are the type of the attributes, and the bottom is supposed to be operations. So the slash represents the derived attribute from the any one of the above. So, and coming to this class attributes having some scope, public is given by plus prefix, and protected given as hash prefix, and private is given by minus or hyphen prefix, and slash is derived data type. So this part, middle part is attribute, and third part is functions or operations of the class. So class name is student, name, address, birth date, register number are the attributes, and eat, sleep, work, play, run, whatever, these are all the operations or functions of the student class. Okay. And next we will see the various ways to draw a class diagram. So the last one is a complete diagram with the proper class name, attributes, and the methods. The first part is class name, attributes, and methods. This also a valid class diagram which is having only class name. It doesn't have the attribute and the function. This also a valid one. So it is having only class name and attribute. That too attribute type is not given. Only attribute name is given. And third part is empty. Also a valid one. This also having 3 sections. First section alone given class name. The rest is empty. Similarly, the third part is given as the only the functions are given. So all these are all the valid class diagram. Okay. And next is in a class diagram, we are having relationship between the objects or entities in a class diagram. So relationship means here we are having 3 types of relationship: dependencies, generalization, and association. So we'll see dependency first. Dependency is nothing but it's a semantic relationship between 2 classes or 2 entities. So here class name is course schedule, class name is course. So the course schedule is depends on the course. So without course schedule doesn't exist or meaningless. Okay. So semantic relationship between the two classes or two entities is called as dependency relationship. So next one is generalization. So generalization means it's a kind of inheritance. So person from the person class, student class is getting inherited. It connects the superclass to subclass. So arrow, check out the arrow. So from student classes deriving from the person class, attributes, methods, functions are shared between the two classes. And check out this generalization where teaching assistant class is inheriting from student class and the employee class and the two base classes. Yeah, coming to the association. So association means connection between two entities, two classes. So student class, instructor class, there is a link between. That's what called as association. A student is learning from the instructor, or instructor teaches the student, whatever it is. And here, check out the multiplicity in the association. Student can have one or more instructor. Student can have one or more. Star represents, asterisk represents many. One or more instructor. Check out this one. Instructor teaches one or more student. Okay, so multiplicity. Uh, this also possible. Instructor teaches one or more student. Student learns from one or more instructor. So multiplicity between two classes is explained here with the multiplicity property, one to many. Okay. Sometimes we also able to name the membership. So student is a member of a team. Student is a member of team, which means student is a membership of one to many team. Team has a member one to many student, vice versa. Okay. So that is what the association. Sometimes we are having, check out this association is self association. Then class as having relationship with on its own. That's what self association. Check out this association is having a direction. So router class is associated with the domain name server class, where server doesn't have any knowledge about the router. So that is what the direction. So next relationship is in association is aggregation and the composition. Very important in the UML diagram. So here in aggregation, check out this engine, transmission or the constant part of the car. So this engine, transmission, constant parts made the whole part car. Okay. So here the hollow diamond connection is used to connect the many constant part to make one whole part car. So this kind of relationship is called as aggregation. Aggregating the whole constant part to make one whole part. That's what aggregation. So next is slightly same but slightly differ from the first one. So here scroll bar, title bar, menu bar are the constant part of whole window, but the scroll bar, title bar, menu bar will not live independently. So here the filled diamond is used to connect the whole part to, sorry, constant part to make a one whole part. In both the cases, constant part to make a whole part, but in aggregation, the constant part can live independently. Engine can live independently. Transmission part can live independently. But whereas in composition, the constant part cannot live independently. That's the difference between the aggregation and the composition. Okay. So this is an example of composition relationship in the association. So where the human body part, liver, heart, many things are there. Heart is a constant part of constant part which make whole part human body. Human is a class name and the name and age of the attributes, and speak, run, eat, many functions can have here. So here the filled diamond. So aggregation, sorry, composition. So heart is a constant part, cannot live independently, but the constant part can make one whole part, human being. So that is what the relationship in the drawing UML class diagram. And the last component of the UML class diagram is an interface. So it's a dummy class. It doesn't have any implementation. It is having only declaration. So two angular bracket. Inside that you have to specify it is an interface and the interface name. Generally, interfaces are used as a dummy class used in the inheritance actually. So the methods in interface are implemented in the subclass. Okay. So with that, we are completing the class diagram, UML class diagram, also end of the chapter and also end of the module 1 introduction to OOPS.